project is called rocket power. Every science experiment has a question, and my question was, which sized rocket will reach the highest altitude with carbon dioxide fuel? Why did I want to launch rockets? I like launching rockets. Scientists launch rockets to provide research and to get research through research and exploration in space. For example, the scientists from NASA and many other space agencies send rockets up to the International Space Station to conduct experiments there. It's fun! Launching rockets is fun! My hypothesis was that the smallest rocket would launch the highest. I used these materials. 4 empty plastic bottles, 10 ounces, 60.9 ounces, 1 liter, and 2 liters. I used cardstock nose cones to put on top of my rocket. I used tape to tape the nose cones together. I used baking soda and paper towels to make packets of baking soda. I used vinegar and the baking soda packets to make my carbon dioxide. I used my cork to put in the bottom of my rocket when I was launching them. And I used a camera to take videos. Here are my procedures. For one, I constructed my plastic bottle rockets. 1, 2, 3, and 4. I had 2 tests. For test 1, I poured 1 cup of vinegar into my rockets. I added my baking soda packets into my rockets. I placed my cork in the mouth of my rockets. I flipped my rockets over, stood back, and observed altitude. I did the same thing for test 2, except I poured vinegar into my rockets to make them half full. Once again, I put my 1 tablespoon baking soda packets into my rockets. I placed my cork in the mouth of my rockets. I flipped them over, stood back, and observed the altitude. Here are my observations for test 1. 10 ounces. Let's see. Here. Can everybody see that? Here. Let's see. That was 10 ounces with 1 cup of water. Vinegar, I mean. Here's the 60.9 ounce bottle with 1 cup. Let's see where this one goes. So that one was a funny one. Let's see. 1 liter. My assistant held these rockets for me. Watch out!
Oh.
This one went out of the camera frame. Very high. Ouch. That would hurt if you were in that rocket. There's no straps or anything. on cup. I held these.
Whoa.
It went up on the roof and then rolled back down. We're not watching that again. Okay. Next. Here are my results for test 4. The 10-ounce bottle launched the lowest. The 16.9 ounce launched the next highest. The 2 liter launched the second highest. And the 1 liter launched the highest. As you can tell. Let's see. Observations for test 2. And remember that this is half full this time. Let's get that out of the way. That one even went out of the camera frame. It just barely went higher. barely. 16.9 ounces. Half full. Just a little higher this time. Let's see. Next rocket. These two have gone twice in our videos anyway. Okay. Let's get that out of the way. That one went really high. Okay. Oh!
I don't even see it go down. Did it come back down?
It did. Both of the two that went out of the camera frame did come back down, but they went really far. And both of the 1 liter bottles hit the picnic table in our yard. That's where we put the camera so that we could do it. And it went like thud. And if you notice, the camera went like this, like that. Funny. Let's see. Here are my results for test 2. The 10 ounce launched the lowest. The 16.9 ounce launched the next highest. Again, the 1 liter launched the second highest. And the 2 liter launched the highest. My conclusion. My hypothesis was incorrect because the 10 ounce bottle did not have enough space to make much carbon dioxide. The larger bottles launched higher because they had more space. Here's what I've. The vinegar to space ratio has an effect on the height of the launch. The rocket needs the right amount of space and pressure, so more carbon dioxide can be produced and launch the rocket to a high altitude. Oops.
Is that the last slide?
Yep.
Then it won't be able to click to the next one.